Quadratic equations. We graph quadratic equations in lesson 1, a couple different ways. We solved quadratic equations back in chapter 8. Today we're going to solve equations by graphing them. If you remember way back when we graphed lines, linear equations, and we discovered that where the line crossed the x-axis is the solution to the equation, because that is when y equals 0. The same is true for quadratic equations. That's why oftentimes quadratic equations will have two answers, two solutions. When we have our parabola that will cross the x-axis twice, that gives us two solutions. We have sometimes the parabola just sits right on the x-axis, and so then there's only one solution, which is incidentally our vertex. And then the last option is occasionally we will get functions that we don't get real solutions to, and we're going to discuss them more later in this chapter. But what happens there is our parabola doesn't actually cross the x-axis. It is either above or below, and it will never cross. So three possible outcomes: two solutions because it crosses twice, one solution when it's sitting just right on the x-axis, and no solutions when it doesn't cross at all. So in this lesson we are going to be solving quadratic equations by graphing them. All right, so we know how to graph because we graphed yesterday. So if we think back to that, and here I give you a table, so if you wanted to do that, I've already provided you with the fact that x is probably -4, but remember our x equals negative b over 2a, because that's a 1, which is -4. So notice that was my middle number. And that now also, usually I would say always graph a 0, plug in 0, but I'm guessing that that's not going to be part of our graph over here. So if I'm going to give you a graph, I'm going to give you the ordered pairs or the numbers to plug in. So let's start plugging these numbers in. So when I plug in -4, I'm going to get a positive 16 minus 32 plus 12. And that will be, let's see, 16 and 12 is going to be 24, and minus 32 is going to be, is that -8? Or did I do that wrong? 16 minus 32 plus 12. Sorry, yeah, -4. Oofda. So there's our vertex, and there's our axis of symmetry, 1, 2, 3, 4. Right here. All right, so our vertex is at -4, -4. Plug in 3, we've got 9 minus 24 plus 12. So 9 plus 12 is going to be 21, and minus 24 is -3. And remember, if I know -2, -3, I also know -5 is -3 because parabolas are symmetrical. Put in a -2, I've got 4 minus 16 plus 12, and that will be 0. So 2 is at 0, -2 is at 0, which means so is -6, and I could put in -1 just for fun. 1 minus 8 plus 12, and that would be 13. Minus 8 would be a positive 5. So that's 1, 2, 3, 4, 5. All why it's not super important, because what we're looking for is where our parabola, sorry, that's a bad curve, crosses the x-axis. And they cross the x-axis at these two places, which are really nice, pretty integers in this case. It is a -2. And a -6. So those are our solutions to this equation, to this function. All right, where it crosses the x-axis happens to be two solutions. All right, let's come down here, and that's your first example when there's two unique real solutions. Okay, so let's take a look at the next one. What happens if there's a double root? Okay, a double root. Let's see, step by step. First, write the equation in standard form. That means setting it equal to 0. So I'm going to add the 6x over here and get 0 equals x squared plus 9, plus 6x plus 9 because we have to go in descending order. If I find my axis of symmetry, that would be x equals negative 6 over 2 times 1. So negative 3, there's that. I know it's going to go right here, right? Now I'm going to plug in negative 3 to find my vertex. So if I put negative 3 in here, I get negative, so I get 9 minus 18 plus 9, I get 0. So negative 3 comma 0 is my vertex right there. Now plug in 0 for my axis of symmetry, for my, y-intercept. If I plug in 0, so I get 0 plus 9, so 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to also work over here. And I really, prefer more points, but I'm going to stop there because what I'm looking for is where does our parabola cross the x-axis? And I kind of knew from the get-go that my vertex was on the x-axis, so I only have one solution, but it is a double root solution. X equals negative 3. Oops, I have a spot down here for it. Negative 3. And if I were to go back and factor this back from chapter 8, we would have noticed that you get x plus 3 and x plus 3. So when I set it equal to 0, both answers would have given me x equals negative 3 because it's a double root. Well, when that happens, that means our vertex is actually on the x-axis and we only have one solution. Okay, flip our paper over and we will move on to the third possible solution here. If I graph this one, again, set it equal to 0 or put it in standard form, which it already is. Now we're going to find the axis of symmetry. So x equals negative b over 2a. I'm just plugging in my b, which is 3, and a is negative 2, and I get a negative 3 over negative 4, so 3/4. That's not super pretty, but we can do it. All right, so right here I have a positive 3/4-ish. It's going to be around here, right? Let's find my vertex by plugging in 3/4. So I have y equals negative 2 times 3/4 squared plus 3 times 3/4 minus 4. Well, this is going to be negative 2 times 9/16, so negative 18/16 plus 9/4 minus 4, and I know that makes a lot of you uncomfortable, but this is going to reduce to negative 9/8 plus 9/4 minus 4. I'm going to change them all to a common denominator, which is going to be 8. So negative 9/8 plus 18/8 minus 16/8, which is going to give me negative 9 plus 18 plus 16, going to give me, negative 9 plus 18 minus 16. It's going to give me negative 7/8. So just shy of negative 1. So but right here, because it was 3/4, comma, negative 7/8. All right. Now, the interesting thing about this is I know, because a is negative, I know we have a maximum value. Right there's my maximum. Okay? So think about that for a second. I'm going to go ahead and plug in 0. If I plug in 0, I get negative 4. So 1, 2, 3, 4, and it'll be over here somewhere. Good morning. And I don't have a solution because this parabola doesn't cross the x-axis. So it actually means you don't have a real solution. You'll find out later as